You might have been taught that you have to learn the times tables by memory, because the multiplication facts are random and arbitrary. But that's a lie, which I learned from this interesting teacher named Fred Duckworth. As an example, let me show you how to learn the 8 times table lickety-split.
Okay, cool.
Let's use 8 times 3 as our first example, and begin learning the products using simple patterns and basic logic.
Okay.
The key is to start with an easier fact, which we get by multiplying the other digit times 10, which is the other digit that is being multiplied times 8.
It's 3.
Obviously. And what is 3 times 10?
30.
Right. But 30 is too big, because we want the product of 8 times 3, not 10 times 3. 30 is too big because 10 is more than 8. But how much more?
10 is 2 more than 8.
Exactly. And since 10 is 2 more than 8, to get 30 down to the correct size, we have to subtract the extra part times 2. The extra part is 3.
So what is 2 times 3?
2 times 3 is 6.
Precisely. So to get the correct product, we have to subtract 30 minus 6.
30 minus 6 is 24. It most certainly is. And that's why 8 times 3 equals 24. But we can't stop there, because now that you've seen for yourself how the logic works, we're going to make this about 1,000 times simpler by using a shortcut.
I love shortcuts.
Well then, you're going to really have fun with this. We've established that multiplying any digit times 8 is equivalent to multiplying that same digit times 10, and then turning right back around and subtracting that digit from the resulting multiple of 10 twice, given that 8 is 2 less than 10.
Right, okay.
Now, if that digit is 5 or less, it logically follows that when you subtract it from a multiple of 10 twice, you're only going to throw yourself back into the group of 10 immediately preceding your starting point.
Oh, I get it. So 2 times 8 will have a 1 in the tens place, and 4 times 8 will have to be 30-something.
Precisely. If you can represent that digit on your hands and fingers using just one hand, you subtract exactly 1 from that digit to get the first half of any 2-digit product in the 8 times table.
Fantastic! But what if it takes 2 hands to represent that digit on your hands and fingers?
Then you subtract exactly 2 from that digit to get the first half of any 2-digit product in the 8 times table.
Oh, I see. So 9 times 8 has to be 70-something, and 6 times 8 must be 40-something.
Right. Because if that digit is greater than 5, it logically follows that when you subtract it from a multiple of 10 twice, you're going to throw yourself back 2 groups of 10 from your starting point instead of 1 group, which is like subtracting 2 from that digit to get the tens place.
Sweet, so I don't need rote memorization at all.
But what about the ones place?
Well, subtracting 2 times the digit is like starting from the tens place and adding back in 2 times the difference between that digit and 10. You start from the opposite direction and do the opposite to get the same result. So the ones place is going to equal 2 times the number of fingers that are not used when representing that digit on your hands and fingers, regardless of whether the digit is greater than or less than or equal to 5.
Super sweet. So I don't have to memorize the 8 times table one fact at a time.
5 times 8 will be 40-something. And since representing 5 on my hands and fingers uses all 5 fingers, there are no unused fingers on that hand. And since 0 times 2 equals 0, 0 is what goes in the ones place. So 8 times 5 equals 40. Exactly. 3 times 8 will be 20-something. And since representing 3 on my hands and fingers presents me with 2 unused fingers, 2 times 2, which is 4, goes in the ones place. So 3 times 8 equals 24. 8 times 9 equals 70-something. And since representing 9 on my hands and fingers presents me with 1 unused finger, 1 times 2, which is 2, goes in the ones place. So 9 times 8 equals 72. Precisely. So you see, there's nothing random or arbitrary about it. The fact of the matter is,
You can learn all the products of any given multiplication table in one single lesson merely by using basic logic.